Okay, this is 5.2, slope and y-intercepts. Now we're kind of moving in from talking about proportional equations to linear equations of the form y equals mx plus b. Let me just explain that here just a little bit. This is what we use most of the semester, a simple equation where the input times some ratio that we call k is equal to the output. All these are proportional, all the solutions are proportional, and the line that's formed by this always goes through the point 0, 0. The only difference between this and this is b, which is the initial value. In high school, maybe they called it the y-intercept. Either one, but really it's the starting place. So it doesn't start here like proportional relationships, it starts here. So that is the y-intercept. When x is 0, that's the y-intercept. So you might want to pause this, oops, and read this over a little bit. The constant rate of change, steepness of a line, ratio of total change in output to the total change in input. And here is like a formula for determining it, for calculating it. I'm sure you've seen that in high school. So you might want to pause this for a minute and take a look at that. So in this worksheet here that we're going to be doing, starting on here, this page, which is 201, we're going to ask you to interpret the meaning of the slope. This is obviously a linear equation. And here's the slope, and we're trying to interpret the meaning. This is how you can do it. The output is changing by so many y units per x unit. Because the slope, remember, is the change in y, or the change in the output divided by the change in the input. That's how you would calculate it, right? And there it's calculated. So I'm going to interpret this in real world terms using this idea here. So I can say that the cost is increasing by $0.05 per minute. Dollars per minute. Output over input. Now we'll take a look at this. So when we first look at this, you got to take a look, see what you got. You got concentration and parts per million. Over here you got parts per million of a pollutant, concentration of a pollutant, and here you got days. So here's the linear equation. It has a negative, so it's going down as you move from left to right. Here's the slope, negative 0.08. Now try to interpret this in real world terms, and that negative 0.08, I'm going to put it down here. You might want to hit pause. So these are the two ways that you can interpret it. You can say the concentration of pollutants, because that's the output. These are the units of the output. The concentration of pollutants is changing by negative 0.8 parts per million per day. Parts per million per day. Another way of saying it is the concentration of pollutants, which is right here, is decreasing by 0.8 parts per million per day. The slope, parts per million per day, there's the numerical value. So we'll look here at the population of Houston. Go down here. Population of Houston. Growth in the Houston metro area. You have that number there. And that number there, hopefully you know what that means. That means 5 times 10 to the 6th power. So the decimals after the 5 move it 6 places. 1, 2, 3, 4, 5, 6. Back 3, comma, back 3, comma. So that's the initial value of 5 million. And that's the years since 2000. So that is not year 0, that is year 2000. Year 2000, that was about how many people they had. So interpret the slope in real world terms. The Houston population is increasing by 123,139 people per year. Right? That's the slope. So I'm going to do one calculation of a slope in some kind of context. Population of a small town of Alaska. What is the rate of change? The data points I gave you is the year and the population. So that's the input, that's the output. That's X, that's Y. So it's Y2 minus Y1. So I can go 210 minus 150. So that's 210 minus 150 over 2010 minus 2000. And that's going to equal 60 over 10. Which equals 6. Still a ratio, though. It's 6 over 1. And what's the meaning of it? Think about it, and I'll put it up there. The real, in words, the meaning. So there's the meaning of it. The population of a small town in Alaska is increasing by 6 people output per 1 year. So that's 6 over 1.